This is Voices for Climate, the podcast where activists, scientists, innovators, and everyday people speak out for our planet. If you're looking for honest conversations, bold ideas, and real climate solutions, you're in the right place. My name is Arnav, and today we're joined by Angela Seligman, a geoscientist and climate advocate focused on deploying superhot rock geothermal energy as a key zero carbon solution. With a Ph.D. in Geological Sciences from the University of Oregon and extensive research experience in volcanology and geochemistry, Angela now serves as a Senior Geoscientist at the Clean Air Task Force. She's worked across science, policy, and advocacy, leading initiatives on carbon capture, air quality, and low carbon futures. Angela, it's great to have you here.
Oh, it's great to be here. It's my pleasure.
Yeah, so to start off, can you share kind of what drew you to geology and the study of volcanic systems in the first place?
Oh, well, yeah, I've had a passion for the earth since I was young. I have these memories of going to camp. I grew up in St. Louis, and the camp that I would go to, St. Louis it's a sprawling city, but the camp that I would go to just was in the forest, full of trees, and just hiking around all day. And just ever since I've been young, I've just had a true passion for the earth. And I knew I wanted to do some sort of work in the environment when I went to college. And I started out studying environmental science and had an emphasis in administration and policy. But I honestly took my first geology class and learned about volcanoes, and it was kind of done from there. And so I just immediately switched over to study geology, and I worked with my academic advisor there, and she gave me a master's thesis to map I did my undergrad at Northern Arizona University, and so that's near the San Francisco volcanic field. And she gave me a project of mapping one of the small non-active volcanoes in the region, and I just got to hike along the lava flows for a year and mapping everything with my field partner and have really just gone from there and continued just a love for the earth and a love for science and being able to just understand everything better.
Yeah, that's a really amazing story. Now you work at the Clean Air Task Force. So can you tell us a little bit more about what that is and what your work involves?
Yeah, absolutely. I took a bit of kind of a long path to get over here. As I had mentioned, I had started out with some emphasis in administration and policy in my undergrad, and so it kind of makes sense that I took a bit of a detour and worked on policy for a bit. I worked as a regulator actually for the state of North Dakota for about 4.5 years before I came over to Clean Air Task Force. But that's what I feel like really got me into being able to do a really good job at the work that I do now because I understand the science and I understand how policies and regulations work at the same time. And really being able to have both of those skills is pretty unique for one, but then also just helps you see the world in a bigger picture, rather than just through my comfortable view of looking at the rocks and understanding the earth. But I started out on our state policy team when I joined Clean Air Task Force and really got to dive into work on state climate policy across the entire US. And then, but then still, I felt like I was kind of missing that science feature in my work. And so Clean Air Task Force let me move over to our carbon capture team from there, but I was still working on federal policy on carbon capture and sequestration. But then from there, I had a great time. Really got to then understand a bit more about federal policy as well. But then there was an opening for this geoscientist position in our super hot rock geothermal team. And that was just something that I really couldn't pass up because if you combine that old love that I have for understanding volcanoes and the heat from deep within the earth and really being able to dig into my science and geology background, but still having that understanding of policies and regulations. This was just the perfect fit for me.
Hmm. Yeah, that's really amazing to hear. And so, I think I find it personally interesting that, you went from first a policy background to now focus more on like the science and geology. And so, kind of given this unique blend of experiences, how in your work do you combine kind of the science work you do with your policy experience? Like, how do those things kind of interact, intersect?
Yeah, that's a great question because it might not seem like it when I put blogs out or host webinars or speak on panels, but really having that understanding, even from a basic perspective, that a policymaker probably isn't going to read more than one page, front and back, that you would give them on something. And so you really have to learn to be able to speak about really technical things in a really easy way to understand, and also to understand that sometimes you need to put out a long report. Sometimes that report, it might be 50 pages, it might be 100 pages, depending on who you want that audience to be for your report. But if you want to be able to reach policymakers or reach the general public, there needs to be a second piece that comes out along with that is not 50 pages. A piece that is maybe just one page front and back, and then to be able to hand that page off to somebody and have written it in a way that anybody can understand what your main point is and why you put that out there and why it's important. And that is something that is kind of hard for scientists to be able to do sometimes, because I even myself was trained for years to write in a really technical fashion, and to be able to just speak between other scientists who already understand your research, but to really be able to understand that if you want to move that science past your inner group, you have to learn to speak about that science in a way that others can understand too.
Hmm. Yeah, I think that makes a lot of sense, kind of changing the format of the form of kind of your content based on the audience you're talking to. And
Right.
so I guess kind of similarly on the topic of your background, I noticed you did a lot of field work in places like Oregon, but also like Kyrgyzstan and Russia. And so how did all of these diverse and international experiences even shape kind of your understanding of our Earth and energy future today?
Oh, absolutely. One thing I've found that's really just really interesting as a geologist is you can you can go to a different country and the cultures are different. There are a lot of things that the average person would see, and everything is completely different. But the geology, going from one area of so if you think about the Ring of Fire around all of the volcanoes that erupt around Japan and Kamchatka and Alaska and the Pacific Northwest, the those types of volcanoes are there's a lot of things that are the same, even though the region that you've gone to is really different. And so thinking about regions that are interesting to a geologist are not always the same as places that are interesting to people to travel for fun. But I do think that it does all give you at the same time just a broader perspective of how different regions have different cultures, and might have different ways of thinking and things that are important to them. Just one example is we recently put out a report through Clean Air Task Force and our super hot rock geothermal team on enhanced geothermal systems. These are, if I can dive into a little bit of the background here, I guess one, we haven't talked about what super hot rock geothermal is. It sounds really cool, and it is. If we think about geothermal energy, there's just not a lot of it around the world today, and that's because to be able to develop geothermal usually we need to already have a bunch of fluid underground that can be heated up, and a lot of little cracks through the rock that are all connected so that the fluid can flow through those rocks, get heated up, and then we can bring it back up to the surface to generate electricity. But that doesn't exist in a lot of places around the world. Of course, a good example of kind of these systems is like the Yellowstone National Park, where you see a lot of these hot fluid bubbles coming up to the surface. We have the geysers, but those kinds of areas, we're not going to develop geothermal energy from Yellowstone because that place is precious, and we want to keep some of these areas precious.
Right.
But but the report that we put out is one way that we can get geothermal energy in other regions where we don't already have a bunch of fluid underground that's already being heated up. But we put this report out, and then of course we know not everyone's going to read our report, the full report, and so we have been putting out some different webinars. One for a region in the U.S. we've had so far, and then this morning we had one in Europe. But but this is getting to, I'm finally getting back around to answering your question. The focus of each of those webinars wasn't necessarily the same. It had the same report that it was focused around, and we highlighted a lot of similar features of the report. But then after that, people in the US might not care about the exact same things as people in Europe. And so making sure that you're speaking to the right audience in the way that they will most relate to is, I think, one thing that's really important to remember when we're talking to different groups. And that applies to people in different countries, but it can also apply to people in different states in the US that might have different priorities.
Hmm. Yeah, that makes a lot of sense. And I guess you bring up a good kind of transition to what I wanted to talk about next, which is now your work as about related to kind of super hot rock geothermal energy. So you kind of already mentioned what that is, but can you elaborate more on why it's such an exciting climate solution?
Yeah, absolutely. So well, one, we have our typical geothermal power plants that we have today that I was discussing earlier. But we can't really have geothermal as a major kind of climate technology and solution if we can only access geothermal in a few regions around the world. And so one of those methods to moving those to other areas is through what we call next generation geothermal energy. And that kind of, at least right now, encompasses two different groups. One of those is the enhanced geothermal systems that I was describing. That's where you might just have what we sometimes think of as is some hot, dry rock under you. We don't necessarily have a bunch of hydrothermal activity on the surface or seeing this hot water being brought up. So we might have to go in and create our own little big reservoir underground where we can bring some water in, push that water down, and then have it flow through the cracks in the rock to pick up heat, and then we bring it back up to the surface. There's another form called closed loop geothermal. What might be most relatable to some people is some people have home heating and cooling systems that are generated from geothermal, and that's where you have a series of pipes that you've drilled underground, and then you can flow water through those pipes, and the pipes are long enough that they can pick up enough heat and bring that up to the surface to generate electricity or for home heating. Those are two forms that are they're really starting to be developed more and more, and we're getting a lot of progress on both of those. But what we are working on specifically in our super hot rock geothermal team as is aiming at really high temperatures for these systems, because the main thing here is that the higher the temperature is, the it's kind of the more bang for your buck that you can get. So at these lower temperatures, you're just not going to get as much electricity from the fluid because we just haven't generated as much heat from underground. But in what we call super hot rock geothermal systems, we're aiming for, and I promise I will not get into too much of the nitty-gritty here,
No, please
but
feel free to do so.
the real key here is that we're aiming for a supercritical fluid in these systems. And the important thing there is that when you get to that supercritical fluid, you're then getting it's more energy dense. So you're getting a big bang for your buck. And what we've seen, we haven't gotten a full demonstration of one of these systems yet, because that fluid's just kind of harsh. It's really hot, and
Mhm.
it tends to when material is really hot, chemicals can just flow more quickly. And so there's just a lot of stuff that we have to figure out there. But the really key thing that we've seen, and this is from early projects in Iceland, is that they were able to get a well flowing, that had this supercritical fluid, and they were able to get 5 to 10 times the electricity generation. Could have gotten 5 to 10 times the electricity generation from that one well as we could have gotten from a lower, kind of typical geothermal well that we see. And so that's what we're really aiming for here is not even just being able to have geothermal energy anywhere that it's needed, but also to get even more electricity generated from one well, so that these power plants can generate even more electricity and require less land use around them too.
Wow, that's really interesting to hear kind of more about what your work is. But in what would you say are kind of the biggest technical and scientific challenges to kind of making this like geothermal energy commercially viable, would you say?
Sure, there's a few pieces. One is around drilling. We've gotten really good at drilling underground. That is, for better or worse, that is partially from the oil and gas industry. That is just we've drilled a lot of wells across the U.S., but we need those drillers to help us drill these geothermal wells as fast and as inexpensive as possible. But
Mhm.
to really get to the place where we can have geothermal energy anywhere around the world, there are just some regions where you have to drill pretty deep to get to really
Mhm.
high temperatures. And so we need to work more on our drilling, not necessarily because we can't do it, but because it's just kind of expensive. And
Mhm.
we want geothermal energy to get to a place where it's not the really expensive choice for our clean energy solutions. The other is in these really high temperature wells, like super hot rock geothermal wells. It's just really hard, even after we drill that well, to keep that well from kind of failing or falling in on itself. Because if you think about it, the wells, it's pretty deep. Um,
Yeah.
and then it's not only really, really hot, but it's really, really hot. And then when you pump the colder water down through the well, it gets cold again. So it has to be able to fluctuate through a lot of temperature swings and still work and not fail. The other piece, and this is a little more on the technical side, but um, we don't know very, we know that we can create these cracks in the rock in these really high temperature systems.
Mhm.
But one thing that's kind of tricky is, and I like to think about like Play-Doh when I'm telling people about this. If you think about in the Earth's a little more shallow, where the Earth's surface is kind of cool, it's in the region that we typically think of as the brittle region of the Earth's
Mhm.
crust. And this is like when you have colder Play-Doh, and if you start messing around with it, you can get it to snap and it'll break, right? If you kind of pull it quickly. But deeper into the earth, we get into regions that we call, we're moving from the brittle to the ductile transition. And that's where if we think about our Play-Doh and we warm it up and then we pull it, it might not break. We
Mhm.
know now that we can make these cracks in in deep in the Earth's crust where it is hotter, but we don't know that we can keep those cracks there. And we don't know how to do it well and in a way that will stay there so that we can have these geothermal wells and these reservoirs and these really high temperature systems that work well for, say, 30 years so that we can keep using that system for a long time. And so we need some more research in these areas as well. And then the other thing too is even in the regions where it's not quite as high temperature, we have some of these projects that are doing really well. These are the enhanced geothermal systems in Utah. But what we don't know as well is how long you can keep pulling heat at a kind of a
Mm-hmm.
continual rate from these regions before you have to wait for the heat to really flow back in. And so these are just some more things that need to be researched, but they're not necessarily things that will stop us from being able to commercialize and fully develop this important climate technology.
Hmm. Yeah, that's interesting to hear. And I like the way you put it. They're not like ways that are going to stop us, right? So that's good to hear. And I wanted to ask
Right.
you more. You mentioned how part of the process involves drilling. And so how do you kind of balance, the
Mhm.
promise of this technology, but also with, maybe environmental and kind of community concerns that come with drilling deep
Yeah.
into the earth?
Yeah, yeah, absolutely. And one of these pieces that's just really important is when developers are coming into this regions to maybe want to start a project is the community engagement piece. A lot of time people are of course curious and I understand that not everyone is a geologist. Not everyone has thought about what happens underneath the earth for decades of their life. And so it can be kind of scary to think about someone coming and drilling a few miles or a few kilometers below the Earth's surface and wondering what's going to happen there. But a few pieces are just kind of important to think about as well as I had mentioned earlier, we have drilled a lot of wells for better or worse. These wells are of course not for drilling into regions to pull fossil fuels out from underground. They're for a different reason and they're for us being able to provide clean, reliable electricity. Um, but we've done a lot of drilling and it's been okay. Minus the climate change issue, which is, not a good one, of course, but we can drill into the earth and things are okay. Um,
Mhm.
the other thing that there are a couple of things that people do that do get a little worried about, kind of specifically with geothermal development, specifically in the non kind of typical geothermal um, environments that we think of where we already have the full system developed. And these are in the enhanced geothermal systems is one you need some water, right? You need some sort of fluid to be able to pump down, move through your reservoir to heat up and bring back up for your electricity. And there are regions that they just don't have a lot of water to spare. And and so of course people have questions about that, and that's okay. Um, a couple of things that are really important to consider is that we don't have to use potable water for these systems. So, like one company, Fervo Energy, who's done a lot of work in Utah, they are only using what is called brackish water. And so that's water that would not otherwise be used for drinking or other, it's not potable water. It's not used kind of in the communities typically. And so they are pumping that out from deep underground. And then what happens is they're pumping it through their geothermal system. And you do lose some water in these enhanced geothermal systems because you are pumping it through the rock, but that water is going back underground where they had taken it from. And it's not water that you would otherwise use for for your day-to-day activities at home. Um, and so that those types of aspects are really important when we're thinking about water scarce regions, which we have a lot of around the world, and we want to be able to have geothermal energy in those regions that is not having a negative impact on the environment. The other aspect that people do think about is in these enhanced geothermal systems, we have to drill our wells, and then we have to create a reservoir for the fluid to be able to flow through, and that involves making new cracks underground. And there have been some situations where people have felt an earthquake on the surface of the earth from the generation of these facilities. And that those have mostly happened kind of early on in the development where we're still learning about how to make these systems. But it can be scary. And it's something that needs to and can be managed is the other important piece there is we've started to have more best practices around geothermal development of what we like to call traffic light systems. And this is where you first have to understand your geology or your rocks really well in your region. You have to know where any existing faults are that you don't want to trigger because you don't want to create a large earthquake. Some of these earthquakes are really, really small, and you want some of those. You don't want people on the surface to feel it, but being able to generate some of these earthquakes and tracking them allows them to, you're not seeing the reservoir because it's deep underground, but you're in a way it's helping you to visualize where your cracks are that you're creating. But these are really, really small earthquakes that we can measure, but you can't feel. And then in these traffic light systems, you'll have a green, a yellow, and a red, kind of like your traffic lights that you see when you're out driving. And the green means we are good to go. We're measuring some earthquakes, but they're really, really small and nobody can feel them on the surface. And then if you can then also have your slightly larger one where you say, these are getting too big. We're a little worried that if we keep going in this direction, that people might end up feeling these earthquakes, and we don't want that. And then you can pull back on what you're doing. So the important piece there is that it's something that we've learned how to manage, but something that we need to make sure that we are managing because having a bad earthquake happen from the production of the geothermal energy is that would not be helpful for the industry moving forward. And this is a really important technology for helping to slow climate change.
Hmm. Yeah, that makes sense. And it's good to hear that kind of all of these things are being considered, especially in terms of communities and kind of the drilling aspect of it. And so, I'm curious, how does geothermal energy compare to things like wind, solar, like nuclear energy?
Yeah, so they one important piece, and I want to start by prefacing, wind and solar are great sources of clean electricity. And we need to be able to build out all of our sources of clean electricity, but we also need a lot of electricity as well. And so we need to build out more. So just even from one perspective, having more options on the table is important in and of itself. Um, a couple of things that are really nice about geothermal energy are that one, the facility just doesn't have to take up that much space relative to wind and solar. Because for wind and solar, you need a lot. You need a lot of your wind turbines and you need a lot of your solar panels. Um, and in geothermal, it just you need some wells and you need your power plant, and that just doesn't take up as much space. And that's kind of like nuclear energy too, where you get a lot of electricity generated for a small use of space. The other thing too is what we like to call clean firm electricity. So geothermal is a form of firm electricity where it can be available 24 hours a day, 7 days a week. The earth is always hot and it doesn't cool down. The other thing that some people ask that I'll maybe just throw in there is we don't need to worry about pulling too much heat out from the earth. We're not going to cool down the earth by generating geothermal energy. And I don't say that as a joke. I think that's a people that don't understand the earth, that's a fair question for people to ask too. Um, but wind and solar, they're really important to have as well. But solar panels, the sun doesn't always shine and the wind doesn't always blow. And so you just have to build more of those to be able to have kind of the same kind of availability of electricity relative to geothermal, where you drill your well, it has a really high upfront cost, which is one of the barriers to developing. But after you've drilled your wells and you have your power plant running, it's always there and always available, which is a little bit different than wind and solar energy. And so kind of comparable in that front to nuclear energy as well.
Hmm. Yeah, that makes sense. And so, you already talked about one misconception, which was about, like cooling down the earth too much. But are there any other like misconceptions about geothermal energy or things you would wish people would like, wish to correct people on, I guess? Any big
I
misconceptions?
think, yeah, and one is that we haven't figured out how to do it, just in general. I think people understand that we already know kind of the typical commercial type of hydrothermal system where that I've described earlier, where we already have plenty of fluid, plenty of cracks in the ground. But people don't really seem to know that we've figured out other types of geothermal systems, and these are like our enhanced geothermal systems that I've discussed. They it's kind of partially because geothermal's name just isn't really out there. It produces currently around 0.4% of the electricity produced around the world. And so it's a really small piece of the pie. And so even just from a very basic level, people don't know about geothermal energy. I think they know a bit more about, I think more people are starting to get things like heat pumps or geothermal heating and cooling like in their homes. But from an energy source, I think a lot of people don't realize that it is a real and reliable source of electricity, and that we've already developed it in a lot of regions around the world, and we're starting to get more and more regions even away from that typical what you think of as a geothermal system.
Hmm. Yeah, I see. And so, if kind of this geothermal energy is successful at scale, which, hopefully it is, what do you think the world looks like by like 2050, when
Mm.
more geothermal energy is, being used?
Well, I think, one, would love that, just from a very basic perspective. Um, but we are hopeful that kind of through mid-century or around 2050 that, well, one, we generally expect there's going to be more need for electricity. So we're not necessarily just replacing other sources of electricity generation with geothermal, right? In some ways, we will, in a realistic perspective, have to produce more electricity, and so partially from from just adding on more electricity to the grid through geothermal. I honestly cannot remember. There is a number of what the IEA put out a future of geothermal energy. It's a long report, but they looked at how much through kind of growth of electricity. I don't want to say a percentage because I can't remember it off the top of my head, but there was a decent chunk where they were kind of projecting with the growth of these forms of next generation geothermal. These are kind of getting outside what we typically think of for geothermal energy, that geothermal could make up a pretty decent chunk of that growth in electricity generation that's needed by that point. And just even as well, one of our goals at Cleaner Task Force is to just get geothermal out of the other category. Like when people are talking about the percentage of electricity that's produced from a given type of energy source, like wind, like solar, like coal, um, geothermal is typically just lumped in the other category, off on the side, and we'd really love to get it out of that other category and just get people learning more about, you know, the the potential uses of geothermal energy.
Hmm. Yeah, that makes sense. And so, my last question to you then is for kind of young people like high schoolers and college students who are interested in the field and, helping to get geothermal energy out of the other category, what advice would you give them to, kind of dip their toes into the field?
Yeah, absolutely. We're going to, I have seen a lot of things about, and I promise I'm not saying this as a geologist. I have seen a lot of things out there about how we need more geologists because we can't develop geothermal better without being able to bring in these experts in the earth and understanding the rocks, understanding how to site a good geothermal area to produce a reservoir, be able to tell your driller what kind of rocks you're going to drill through, where are the faults that we need to worry about so that we aren't triggering earthquakes when we're developing our geothermal reservoir. Um, we need more geologists. We need those experts. We need people who are excited to start new geothermal companies and kind of take the reins to go to new regions and be able to bring in those expert geologists too to be able to site these areas and develop new projects. We also need more engineers to be able to build out these wells, and we need researchers to be able to run tests either in the lab, as you kind of think about the typical person in the back lab running experiments, as well as hopefully larger labs, like we have one at there's a DOE funded project in Utah as well, where you can kind of test the development of these enhanced geothermal systems. So we need researchers too, so more scientists as well. We're hoping this is a large growing field, and so we really need a lot more people coming in so that we have that workforce.
Hmm. Yeah, that makes sense. And I think that's such amazing advice and a powerful note to end on. So, Angela, thank you so much for joining us today and sharing your experience and insights. Really appreciate, you spending your time to speak with me.
Yeah, happy to. It was my pleasure, and thank you for the great work that you're doing in getting the word out on this as well.
Thank you. And so that's all we have today on Voices for Climate. If you enjoyed this episode, be sure to follow the show and share it with someone who cares about building a more sustainable future. And I'll see you all next time. Thank you.